This is a video of the PowerPoint. You can go ahead and pause the video at any point to take notes, and I also posted the slides themselves without the video if you would prefer to use that. So this is 1.1 day 2. There we go. So a data set could involve two categorical variables instead of just one that we were looking at earlier. An example of this is something we talked about already, where you can see a little over 4,800 students were asked, what do you think the chances are that you will have much more than a middle class income at the age of 30? So something you should have in your notes is a picture of this. So this is the data resulting from this, and I'm going to grab my pointer here, and you can see it's divided by gender, female and male, and on the far right your totals, and there are 5 categories over here. So what you just saw was a two-way table, and that's a way that you can describe two categorical variables in one table. You obviously have rows and columns. Here is a smaller version of the table we just looked at, and a couple questions you could ask yourself would be, what are the two variables described? And in this case, we're looking at the top and bottom, or the top, would be gender, female and male, and this would be your choice, basically, your opinion on your answer. So I wrote gender and opinion. Now you could ask several questions here. For example, what is the total number of students? You could also ask the total number of just females or just males, but the question I put in here was how many young adults were surveyed, so that would be right here in the bottom right corner, 4826. On the next slide here, just going through a few things, it says that you should look at the distribution of each variable separately as we're going along. The distribution shows how often each outcome occurs. The total column on the right has the totals for each row, while the total column on the bottom has the totals for each column. That lets you label these appropriately as well. Now, if the row and column totals are missing, the first thing you should do if you're looking at a table is to calculate them and write them down. Finally, here's a definition for you. The distributions of opinion alone or gender alone are called marginal distributions. That's because they appear on the right and bottom margins of the two-way table. Now you're going to notice that quite often percents are a good way to look at the numbers instead of just purely the numbers themselves. So in order to do that, which is examining a marginal distribution with percent, you should calculate those marginal distributions in percents, and you can do that for the rows or columns. You should also make a graph to display the marginal distribution. So as a quick reminder here, to get a percent of something, you want to take one of the totals divided by the overall total amount. So in this case, we're looking at the number of people that said almost certain, which was 1,083, divided by the total number of people, which is 4826. Converting that to a percent would be 22.4%. So on this next slide, we have the table once again, and we're going to examine the marginal distribution of the chance of getting rich. So in the table to the right here, we see one way you could break it down into percentages. For example, on this first one, the 194 came from adding 96 females and 98 males who said almost no chance, and divided that by the total number of people answering the question, which basically tells you that 4% of the people said that. Now from there, you could do that for each of the 5 categories and put it into a bar graph. Okay, notice the 4% here. This is approximately 4% right there. So it's another way of looking at it and hopefully making it make sense. Now here's another example. Here it says we have a random sample of 415 children ages 9 through 17 from the United Kingdom and the United States who completed a survey in a recent year. Each student's country of origin was recorded along with which superpower they would like to have. And you can see those are the ability to fly, freeze time, invisibility, super strength, telepathy, which is the ability to read minds, and all of that is summarized right here. So it says here, we're going to use this two-way table to calculate the marginal distribution in percents of these preferences, and then we're going to make a bar graph to display the marginal distribution. So you should make sure you copy this table down, but leave some space on the side because we are going to add to it. So first off, you would figure out what the totals are. Now, you can see here the percent of people that said fly was 23.9%. That came from adding the 54 and the 45 and divided by the total number of children that responded. They did that for each of these categories. And if you put that into a bar chart, it could look something like this. Now, this is combined United States and United Kingdom. It's not looking at the countries separately. We're going to be doing that a little bit later. The next topic I wanted to talk about was a conditional distribution. Basically, a condition means that and we're not looking at all the data, we're just looking at some of the data. For example, on the chart we just looked at, a condition might be we're just looking at American kids, or we're just looking at kids from the United Kingdom. So, how to examine or compare conditional distributions? You have to decide which row or column that you're interested in looking at. You would then use the data in the table to calculate the conditional distribution in percents of that row or column. And finally, you'd want to make a graph to display this conditional information. Now keep in mind, you can make different types of graphs. You can use a side-by-side bar graph, for example, or something called a segmented bar graph. I'll show you an example of both. So here we are again with the table with the chances of getting rich that you've seen already. So we are going to do two things right here. First, we're going to calculate the conditional distribution, and the condition on the first one is going to be that you are male, and the condition on the second one is going to be that you are female. So here is the one for the males. Now where did this come from? The total number of males, 98, that said almost no chance, divided by the total number of males. So that would be the conditional distribution of these 5 things if you were male. You could do the exact same thing for females, and that chart would look like this. Now combining those two into a different looking chart, we could have a side-by-side bar chart. This is the same information. For example, 4 and 4.1 for almost no chance. They should be very, very close right here. Okay, so this is a side-by-side bar chart. Next, I'm going to show you a segmented bar chart, which is another interesting way to look at it. Here it is right here, a segmented bar chart. And notice they're stacks, and you're still comparing the two. This time we have males on the left and females on the right. Next, I want to talk about what does it mean to have an association. There is an association between two variables if knowing the value of one variable will help you predict what the value of the other variable will be. So here is our segmented chart again that you saw on the previous slide. So a question you might ask, can we say there is an association between the gender and the opinion in the population of the young adults? Okay, does it matter? Are the males and females different? So hopefully you can look at this chart and say, well, they're not identical, so it does appear that there are some differences. So one conclusion you could make here, it says, from this data, men seem to be a little bit more optimistic about their future income than the women. And you can see that right here, the total of the purple and the red, which means almost certain and good chance, are larger than the purple and the red for the women. Okay, so you can make other conclusions there too, but that's the only one that I pointed out right here. A couple more slides. So here is back to our example of the superpowers. So it says, let's complete our analysis of this data looking at the table. So first off, it says we're going to find the conditional distributions of those superpower preferences among the students from the two areas. So one thing I would like you to do or keep a note of here, and I'm going to try to change a setting on my other screen, so we'll see if this works. We need to total these. So over here you can see that the total, if you add all these together, is 215. Actually, I think I might have that the wrong way. I think this one was 200 and the other one was 215. So you do need to keep that in mind. The total of the UK is 200 students were asked, and the US was 215. Okay, I'm going to go to the next slide. All right, on this next slide, you can see that we can break it down. Notice for the UK, we divided each total by 200 to get our percentages, and then I put it into a side-by-side bar graph on the right. And the last question, right here, I have, is there an association? Well, you can look at a few things. It says, for example, the UK seem to be more interested in flying and freezing time. The US seems to be more interested in invisibility and telepathy. And both countries were much lower on the super strength. All right, that's the end of my video. The last slide here is just a summary of the things that we went over in this section.